Hello, everyone. This is Mr. Garcia. Hello, hello, hello. I'm about to show you guys the instructional notes for 1.3. So hopefully you are in the 1.3 handout. So this is the handout 1.3. Here's the do now. Make sure you do the do now. But we're actually going to make sure you do the think, pair, share as well. And then we're actually going to go to the notes, okay? So make sure you have your notebooks ready because we're actually going to go over the notes, okay? So very quickly, here we go. The thing that we went over today on 1.3 is what is total energy, kinetic, and potential energy, right? So we have right here, let's start off with total energy. Total energy, if you read your do now, basically total energy is potential plus kinetic energy combined. So kinetic energy plus potential energy. Okay? Now, energy, no matter what kind of energy it is, the units for energy will always be joules. So whether it's chemical, mechanical, kinetic, total, potential, radiant, thermal, whatever it is, the units will always be joules. And it's pronounced joules like jewelry, joules, okay? So that's the units for this, okay? Let's look at some quick examples though, right? I always want you guys to look at some quick examples. Oh, wrong one. Okay, let's look at some quick examples. Okay. Let's say we have, for example, we have 30 joules. That's supposed to be 30. Oh, that's not like that way that turned out. That's not 30. That's a weird 3. 30 joules, let's say 20 joules, and then let's say negative 150 joules, okay? And then on the other side, for potential energy, let's say it's 30 joules. Let's say it's 60 joules, and let's say it's 300 joules, okay? Now, the total energy is basically them just added together, right? So let's take 30 joules of the kinetic energy and 30 joules of the potential energy, and let's add them together because that's going to be our total energy. 30 plus 30 equals 60, but not just 60, it's 60 joules. Next one, 20 joules plus 60 joules. 20 joules from the kinetic energy, 60 from the potential energy is going to be 80 joules, okay? And the last one, there's actually a negative number. So we know 300 is bigger than negative 150. So 300 minus 150 is what? You guessed it, 150 joules. Okay? Don't forget, these are the units. The units are very, very important. So we know what kind of measurement it is. And we know it's energy because it's in joules. Okay? Move on to the next one. There is a specific type of potential energy called gravitational potential energy, right? Gravitational potential energy. Okay? And that one is just potential energy. It's just potential energy affected by gravity. Affected by gravity. So we know kinetic energy is releasing energy when they're moving, and we know potential energy is storing energy when it's still, when it's not moving. So specifically, gravitational potential energy is potential energy affected by gravity. So at least on Earth and on any planet or any area that has gravity on it, every single object, oh, let me do that different. I'm gonna put everything is affected by gravitational potential energy, or GPE for short. So everything is affected by gravitational potential energy. That's cars, water, the air, ourselves, buildings, anything that has gravity, like Earth has gravity, everything's affected by gravitational potential energy because gravity is pushing us down. So to be more specific, that force is pushing us down. That force is pushing us down. So pushing down. Okay? Pushing down. Let me pause this. Okay, sorry about that, guys. I had like a meeting that I forgot I had to go to, so I had to stop halfway through. But to where we left off, yes, if you anything gravitational energy pushes it down, right? So it's always going to push you down. Okay, always going to push you down. Okay, gravity. There's a reason why we don't fall off the face of the earth or go flying around or go into space, is because gravity pushes us down and keeps us grounded. Next one. On to the next one. Let's see. Oh, I already did that one. Yes. Let's do this. I'm going to erase this real quick just so we can actually see how the process of that. So let's say, for example, we have a swing, right? My bad. I pressed pause. Just a nice little swing, right? A little swing. Back and forth, right? Back and forth swing. Now, at different times, it is going to be placed in a different location, right? So sometimes it could be up here, it could be down here, another time it could be up there. It just depends, right? Now, something I want you guys to know is that at the highest points, so whichever ones are the highest points, right? Those have it's where it's resting. So resting, okay? At the highest point, it is not moving. Not moving. If you try that with an actual swing, like if you actually like gone the swing, when you swing, you only go so far, right? You only go so high. And at the highest point, you kind of like stop. It's like very fraction of a second when you stop. That's where it has the highest potential energy. The highest gravitational potential energy, to be specific, because it has to do with gravity, right? So the highest gravitational potential energy, that's when you're resting. You're not moving at all. So that's the most potential energy that you have. Now that means that there's no kinetic energy because you're not moving. You're resting, so there's no potential energy, okay? So there's no kinetic energy, right? However, at the bottom part, right here, at the bottom part, you have the highest. That's when it's moving the most. So at the lowest point, it is kinetic energy and it is moving the most. Right? It is moving the most. That means that at the lowest point, you are going the fastest. So that means there's a very minimum, there's still gravitational potential energy. There's still some gravitational potential energy, but it's very low, very, very low, because you're not resting too much. You're actually moving most of the time. But since gravity's still pushing you down, there's still some potential energy going on, right? So you go back and forth, and energy is being transferred from gravitational potential energy to kinetic energy. So at the lowest point, you have the highest kinetic energy and the lowest potential energy. And at the highest point, you have the highest potential energy and the lowest kinetic energy. Okay? So it's very big factual things to know. Okay? And that's pretty much it for those two. And know that potential and kinetic together equals to total energy. So the total energy is still going on throughout and still consistent. The total energy never changes. The total energy doesn't change. Total energy does not change. Okay? Does not change. Okay, and those are the instructional notes on this next on the handout. Once we go to here's a little conclusion one. If you go to your guided practice, there is a table down here, and you have to fill in the table according to what the process are. There are 8 different processes, and each process, 4 different processes, and each one has a kinetic and potential energy process. So I made an example. For example, water held by a dam. There's about 500 joules of energy. You know, if the water is being held, that means the water is not moving, so that means potential energy. But when the river is flowing, that's the water is finally moving, that's kinetic energy. So you put that under the kinetic energy process. And what's total energy? You just add them both together. 500 plus 100 joules of energy equals 600 joules of energy. So there was a total amount of 600 joules of energy from the 100 joules of energy from the flowing river, kinetic energy from the flowing river, and 500 joules of potential energy from the water being holding the dam holding the water. Okay, so you just have to fill those in, right? Once after you do that, you will go down here and you will click on this, and it will take you to a site where you have to post on Piazza, and you basically have to post an example of potential kinetic and total energy, right? So here's the instructions, and if you go down here, I have an exemplar right here of Mr. Castillo doing an example of water. Water, when it's not boiling, is potential energy. Water, when it's boiling, it's kinetic energy because it's moving. But the total energy is the sum of both of them, so there's actually no loss of energy happening. Okay, so that's pretty much it what you guys have to do. Okay, I'm actually going to stop this because I don't want you guys to be too long. But let me know if you guys have any questions. Okay, these are the instruction notes. Okay, have a great day. Bye-bye.